In this tutorial, I will be introducing about rack joint and cable joint, starting with rack joint first. As you see in this demo, that in Catia, a rack joint is visualized as a gear turning while carrying the rack to translation movement. Now let's try to build a rack joint. We are in DMU, Kinematic Workbench. As you can see, these parts are already made. All we have to do is just apply the proper constraint to make it work. First of all, we need to fix one component. In this case, I decide to fix the rack support. As the pop-up windows show up, pick new mechanism and name it rack. Then select the rack support. Now verify in the specification tree that you have just created a new mechanism called rack. Next, select rack joint from the DMU kinematic toolbar. It is the third icon on the toolbar. If you don't see it, press on the little arrow and expand the kinematic joint toolbar, and it is one of the last ones. Since rack, it is the mechanism we want to create, there's no point of creating another one. We can also see that rack is composed of a prismatic joint and a revolute joint, and we need to create them. Assuming that you are familiar with the creation of prismatic and revolute joints, I will breeze through this step. Create, match axis of translation, select the fixed plane, and OK. Do the same for revolute joint. Create, match rotating axis, fix the planes. One note that for the revolute, it does not need to be coplanar with the select plane. It can be offsetted by selecting the offset and key in the value. The ratio is how much we want the block to translate per revolution of the rack wheel. I will set it 4 inches per revolution. So, key in 4 IN underscore TURN. Don't worry when you key in English units and it came back in millimeters. The value is the same, just how the Catia is programmed. The rack joint can be angle driven or length driven, and it refers to the driving parameter of this mechanism. In this tutorial, we select angle driven, and left click OK. This is a good sign when you get this message. Before we start simulating, let's change the range of the driving parameter. Go to the specification tree under Rec, and left double click on Rec.1. Change the lower limit to 0, and press OK. Left click on Simulation with Command, and see if you like the results. By dragging the command bar a little bit, I like the result. I will go ahead and close it. Now I have created a rack joint. Now let's see cable joints. As you can see, it is just two prismatic joints moving in the same direction along their planes. Let's try and build it. Again, the easy parts have already been made. Select Fixed Part, name the new mechanism Cable, and left click on the support. Select Cable Joint, which is in the same toolbar as Rack Joint. Here you can see that we need to create two prismatic joints. As usual, create, line of translation, planes, OK. And for prismatic 2, it's the same thing. Create, line of translation, planes, OK. Use length driven for prismatic 2. What the ratio means is that if the ratio is 3, for every 1 unit of prismatic 1 translation, prismatic 2 will translate 3 units. Since our length driven is for prismatic 2, we will leave it at 1. Press OK. That's a good sign. Again, let's change the parameter ranges. Go to the specification tree, mechanism, cable, joint, and double click on cable.1. Change the lower limit to 0 and upper limit to 4. Select OK. Check our work again by simulation with commands. It works very well, so we can go ahead and close it. Choose Simulations from the DMU Generic Animation Toolbar. Highlight Cable and press OK. Click the three dots beside the spin box on the window and change the spin box increment to 0.25 and click OK. Select Automatic Insert from the Edit Simulation window. Now press on the arrow indicate up. Hold it until the value reads 4. Then press on the arrow indicates down until the value reads 0. This is a great trick to add frames to the simulation. Unselect the automatic insert, select the jump to start button on the very left, set the interpolation step to 0.2 and press play. Now we have a simulated cable joint. If you want to make it look more realistic, it is a good idea to add a cable and a roller just for a cosmetic purpose. In this case, I have a rect driven cable and it's still angle driven, and a cable joint that is driven by the rect. Therefore, neither option need to be selected. I also added a revolute joint served as a roller. Since we are trying to simulate multiple joints at once, simulation with laws is a better approach. Go into Formulas, filter type is time, highlight kin time, change the name to a small t, and press apply. Now filter type, select all, and select angle 2. From the specification tree, we can tell it is the driven rect angle. Left click Add Formula, select Rename, and double left click on T. Multiply this value by 90 DEG divided by 1s. That is our angular velocity. Click OK. Do the same thing for angle, except using the angular velocity of 30.5. Now check the laws and you will see two formulas showing. Go to Simulation in the DMU Generic Animation. As you can see, our little trick wouldn't work if we simulate with commands. Select Use Law tab, go to the three little dots and change the time to 4s. Again, use Automatic Insert and insert all the times manually as shown. Unselect Automatic Insert and play. Now this looked more realistic. This would end our tutorial of rect joints and cable joints.